Hola, senors and senoritas. Is everything going well as per your plans today? It's Professor Suresh. Delighted to be back again for my 20th video in process of publication on YouTube today, 25th of May 2020. Topic once again is an emerging one which comes under disruptive technology. It is drones, also known as unmanned aerial vehicles, shortly UAV, infinite applications. An unmanned aerial vehicle, shortly UAV or uncrewed aerial vehicle, commonly known as a drone, is an aircraft without a human pilot on board and a type of unmanned vehicle. UAVs are a component of an unmanned aircraft system, UAS shortly. This includes a UAV, a ground-based controller, and a system of communications between the two. The flight of UAVs may operate with various degrees of autonomy, either under remote control by a human operator or autonomously by onboard computers. Some of you might have used remote controlled choppers, remote controlled cars, radio cars, and all that. This is somewhat similar to that. Okay. Compared to crewed aircraft, UAVs were originally used for missions to dull, dirty, or dangerous for humans. While they originated mostly in military applications, their use is rapidly expanding to commercial, scientific, recreational, agricultural, and other applications such as policing and surveillance, product deliveries, aerial photography, infrastructure inspections, smuggling, and drone racing also. So there is no field that I can think of where drones are not utilized. Civilian UAVs now vastly outnumber military UAVs with estimates of over a million sold by 2015. Wikipedia definition. As a matter of fact, drones continue to be used in India during pandemic novel COVID-19 lockdown period for sanitization of zones, especially inaccessible by humans, and also for surveillance in containment zones, spraying pesticides, etc. from air on agricultural lands. Drones are used during marriages and other ceremonies for aerial photos and videos. Drones are used for spying too by defense, especially. Even terrorists may use drones to collect sensitive information by sleeper cells for planning. So Indian government has imposed a lot of restrictions for drones, like formal registration with the Directorate General of Civil Aviation DGCA, besides legal permission from police for usage of the drones irrespective of their capacity, range, etc. The term drone, more widely used by the public, was coined in reference to the early remotely flown target aircraft used for practice firing of a battleship's guns, and the term was first used with the 1920s Fairey Queen and 1930s de Havilland Queen Bee target aircraft. These two were followed in service by the similarly named Airspeed Queen Wasp and Miles Queen Martinet before ultimate replacement by the GAF GINTV. The term Unmanned Aircraft System UAS was adopted by the United States Department of Defense DoD and the United States Federal Aviation Administration in 2005 according to the Unmanned Aircraft System Roadmap 2005 to 2030. The International Civil Aviation Organization, shortly ICAO, and the British Civil Aviation Authority adopted this term, also used in the European Union's Single European Sky, shortly SES, Air Traffic Management, shortly ATM, Research, CESAR Joint Undertaking, Roadmap for 2020. This term emphasizes the importance of elements other than the aircraft. It includes elements such as ground control stations, data links, and other support equipment. A similar term is an unmanned aircraft vehicle system UAVs, remotely piloted aerial vehicle RPAV, and remotely piloted aircraft system RPAS. A UAV is defined as a powered aerial vehicle that does not carry a human operator, uses aerodynamic forces to provide the vehicle lift, can lift, fly autonomously, or be piloted remotely, can be expendable or recoverable, and can carry a lethal or non lethal payload. Therefore, missiles are not considered UAVs because the vehicle itself is a weapon that is not reused, though it is also unmanned and in some cases remotely guided. Nowadays, it's all called smart missiles and all that because it can take the necessary corrective actions too. That being said, UAV is a term that is commonly applied to military use cases. A drone in a box, DIB, is an autonomous drone that deploys to carry out a pre-programmed list of missions from and returns to a self-contained landing box, which also functions as the drone's charging base. Drones can fly beyond visual line of sight, BVLOS, because that was a restriction those days. You should be able to see the drone while in flight from the ground, while maximizing production, reducing costs and risks, ensuring site safety, security, and regulatory compliance, and protecting the human workforce in times of a pandemic. They can also be used for consumer-related missions like package delivery, as demonstrated by Amazon Prime Air, and critical deliveries of health supplies. That was done in China mainly. The earliest recorded use of an UAV for wars occurred on July 1849, serving as a balloon carrier, the precursor to the aircraft carrier in the first offensive use of air power. UAVs typically fall into one of 6 functional categories, although multi-role airframe platforms are becoming more prevalent. These 6 functional categories are 1. Target and decoy, providing ground and aerial gunnery to target that stimulates an enemy aircraft or missile. That's why it's called decoy. 2. Reconnaissance, providing battlefield intelligence. 3. Combat, providing attack capability for high-risk missions. Unmanned combat aerial vehicle, shortly UCAV. 4. Logistics, delivering cargo. 5. Research and development, improve UAV technologies. And last one, civil and commercial UAVs for agriculture, aerial photography, data collection in naval aviation. Vehicles can be categorized in range, in terms of the range, altitude, as 1. Handheld, up to 2000 feet, which is 600 meters approximately, altitude, about 2 kilometers range. Second one, close to 5000 feet, 1005, which works out to 1500 meters altitude, up to 10 kilometers range. Third one, NATO type, 1000 feet, 10,000 feet, which is equivalent to about 3000 meters altitude, up to 50 kilometers range. Fourth one, tactical, up to 18,000 feet, which works out to 5,500 meters altitude, about 160 kilometers range. 5. Medium altitude, long endurance, shortly called as MALE, for medium altitude, long endurance, up to 30,000 feet, which works out to about 9,000 meters and range over 2,000 kilometers. And sixth one, high altitude, long endurance, shortly HALE, for high altitude, long endurance, over 30,000 feet, which works out to 9,100 meters and indefinite range. Seventh one, hypersonic, high speed, supersonic, Mach 1 to 5 speeds, or hypersonic Mach 5 plus speeds, up to 50,000 feet, which works out to 15,200 meters, or suborbital altitude, range over 200 kilometers, and 8. Orbital low Earth orbit, speed is Mach 25 plus. Ninth one, CIS, lunar, Earth Moon transfer. 10. Computer assisted carrier guidance systems. shortly CAGGS for UAVs. Other categories include hobbyist UAVs, which can be further divided into ready to fly, shortly RTF, commercial off the shelf, COTS, bind and fly, BNF shortly, require minimum knowledge to fly the platform. C, almost ready to fly, ARF, do it yourself, do DIY, require significant knowledge to get in the air. D, bare frame, require significant knowledge and your own parts to get it in the air. Mid-size military and commercial UAVs. 3, large military specific UAVs. Fourth one, stealth combat UAVs. Fifth one, crewed, that means manned aircraft transformed into uncrewed or unmanned, and optimally piloted UAVs or OPVs. Classifications according to aircraft weight are quite simpler. As 1, micro air vehicle MAV, the smallest UAVs that can weigh less than 1 gram, or 2, miniature UAV, also called SUAS, approximately less than 25 kg weight. Third one, heavier UAVs. Most of the things I have stated so far is from Wikipedia. Drone is composed of 2 major systems. One is a movement system, second is a control system. Movement system includes frame, which is the basic element of the drone, which should be maximum light. The classification of frame construction is mainly based on the number of arms. Due to the number of arms and the motors used, the drones can be divided into bicopters with the 2 engines, tricopters with the 3 engines, 3 quadcopters, 4 engines, hexacopters with 6 engines, octocopters with 8 engines. Second component, main component, propellers and engine. The next component of the engine are definitely the engine, the propellers. They constitute the main propulsion system of a drone, which are subjected to the highest loads. Therefore, the durability is very important. The propellers change a torque derived from the engine for a work used for lifting the vehicle in the air. C, the power of a drone. The residence time of the object flying in the air depends both on the type of drive and the type of power supply. A drone is powered by batteries, which is a major drawback because it is exhausted very soon. Okay, those days it was hardly about 15 minutes of flying time, causing a decrease of the drone on the ground. In general, batteries are the sets of 2 or more voltaic cells of the same type, providing a current that is stronger than a single cell. These can be divided into disposable batteries and electric accumulators that can be uploaded and loaded many times. In the batteries and accumulators, complex chemical reactions occur in which, depending on the type of battery, participates many chemical elements. As a result of chemical reactions, the chemical energy contained in their active substances is converted into electrical energy. Batteries are defined as a chemical current sources. The set of active substances and the electrolyte is a basis of chemical current sources action. This set functions in the form of a cell containing positive and negative electrodes and an electrolyte in individual sealed enclosure in the batteries and accumulators. Next one, the electronic control and communication system. The control system is responsible for the drone fly up, down, rotate, but for this reaction to the emerging forces and for stability. Most of the control systems are equipped with the same set of sensors with a difference in the speed of calculations and in the algorithms used. The control system consists of flight controller responsible for machine control capabilities, electronic speed control, shortly ESC, the unit responsible for engine RPM, supplying plate, separating the power supply for regulators, turnovers and motors, subscribers identification module, shortly SIM, like the mobile phone module, which allows the transmission of telemetry data Fifth, proximity camera, an element of anti-collision system, the numeric keypad to enter the customer PIN codes, personal identification number. Military drones differ from civils in size and drive. They are bigger and powered by internal combustion engines. Civil drones are driven by electric motors. Prime advantages of drones are cheap and cost effective, high spatial resolution, high accuracy, easier to deploy, no hindrances from clouds, a great tool for surveillance. Prime disadvantages, on the contrary, are limited capabilities and coverage, care required using in populated areas, chances of misuse illegally, for example, by terrorists, attributed to easy operation. Drones may be multi-rotor, fixed wing, etc. Drones mostly use RGB cameras, LiDAR sensors, thermal sensors, and multi-spectral cameras. Droids, drones, and robots were mainly initially the realm of science fiction writers. Ever since the first robot, Maria, took the form of a film's heroine in Fritz Lang's 1927 film Metropolis. Autonomous machines have gripped our imagination since then. Public health measures in response to the COVID-19 pandemic have introduced social distancing into the narrow national lexicon. Drone companies believe they can help. Drone technology is ready to break out into a mass service and reduce person-to-person contact. There are a few dozen pilot programs throughout the United States and some limited commercial deployments for services such as medical delivery, parcel delivery, utilities inspection, and crop spraying. These programs have shown drones to be technically feasible for the set of tasks tested, and some of them have been even tested business models with a measure of success. Early reports say that in the past month, a major Chinese logistics company made thousands of flights to deliver 11 tons of medical supplies and parcels to areas stricken by COVID-19. Using drones in China reportedly decreased delivery time by over 50% as compared with road transportation, and it took humans out of the process, which helped to decrease the COVID-19's rate of spreading. Drones also brought COVID-19 testing samples to laboratories, which helped the quick diagnosis and quarantining of infected citizens. More importantly, drones were used to safely transport medical supplies into hospitals where COVID-19 patients are being treated. These areas would be dangerous to the average courier who might contract the disease and then go on to infect even more people. But delivery drones make this task safe. Drones have a bad reputation those days to start with. Most people associate them with expensive military aircrafts or small consumer toys because that's how the usage started. However, recent data shows that the future of drones will actually be shaped by practical commercial applications. The usage of drones in business operations has broadened different industries in the last few years due to their ability to drive efficiency and data analytics. Venture capitalists, VCs, have invested a total of $1.5 billion US since 2012 in drone commercial startups that are shaping the industry. Drones can vary in shape and size, but the main core elements, which happen to be the battery, microcontroller, motor, sensors, are essentially the same. Since drones are made with the smartphone parts, investments over the last 10 years in these parts have driven drone prices down, increasing accessibility to consumers and businesses. Drones can be viewed as smartphones with the ability to fly or move. Unlike most financial technology developments such as big data and payment innovation, drones are valuable for the combination of mobile hardware and internet connectedness. Drones are distributed sensors that make the internet smarter. They can serve as a platform on which different applications, software, and business models can be built. Indeed, everything from drone mapping software to flight planning software, drone insurance, and marketplaces for people to find drone pilots has emerged. The drone market will grow steadily in the consumer, commercial, and military sectors. In a 2016 report, Goldman Sachs estimated that drone technologies will reach a total market size of $100 billion between 2016 and 2020. Though 70% of these figures would be linked to military activities, the commercial business represents the fastest growth opportunity, projected to reach $13 billion between 2016 and 2020. UAVs are being utilized for real-time monitoring of road traffic, providing wireless coverage, remote sensing, search and rescue operations, delivery of goods, security and surveillance, precision agriculture, and civil infrastructure inspection. Aerial drones are used for zoning and urban land use planning in Canada. Drones play a key role to distribute critical information at the edge of the battlefield and for deploying long-term evolution, shortly LTE networks in remote locations. Drones are considered as an integral part of 5G and beyond deployments, where these vehicles will be acting as a major role player in coverage and capacity enhancements. With the networking capabilities of UAVs, hadlock formations are seen as one of the key advancements with these vehicles. Advancing from single UAVs to multi-UAVs, such networks are dominantly studied as flying at hadlock networks, shortly FANETS. Drones can be helpful in timely delivering of services, especially during or after a disaster, by increasing the surge capacity for public safety communications. Such an application allows temporary setup of the communication network at a comparable capacity with the traditional setups. Integrated network formations are other examples of drone assisted communications. Such coordination can be observed between UAVs and wireless sensor networks, shortly WSN. Both of these networks can support a large set of civilian and military applications, which include search, navigation, control, and reconnaissance. In spite of providing a large set of applications and wide coverage, data dissemination in FANETs remains a concern because of the high dynamics of aerial vehicles. Additionally, frequent topology changes and 3D space movement makes routing a tedious task in FANETs. Surveillance has been one of the major applications of UAVs. Modern UAVs available in the market are well developed to cater to the countless fields of applications. UAVs have their own limitations in terms of flight range and maneuverability. The traditional fixed-wing UAVs, shortly FW UAV, can fly for long distance but require runways or wide open spaces for takeoff and landing. On the other hand, the more trending multi-rotor UAVs, shortly URUAV, are extremely maneuverable but cannot be used for long distance flights because of the slower speeds and relatively higher consumption of energy. To bridge the performance gap between RUAVs and FWUAVs, the solution is to have a hybrid vehicle takeoff landing, shortly VTOL aircraft. This type of aircraft will have the advantages of both fixed wing and multi-rotor type UAV, and to a substantial extent should be able to eliminate the shortcomings. In the aviation industry, major companies have already successfully mass produced and commercialized numerous models of VTOL aircraft. The tilt rotor mechanism is only one of the concepts that are proven for successful VTOL flights. The hybrid VTOL UAV design, however, has its own shortcomings compared to both the fixed wing and the multi-rotor type UAVs. The addition of extra propulsion system to cater for horizontal and vertical flights resulted in significant extra weight carried by the vehicle. Normally, a conventional RUAV multi-rotor type model would only need 4 brushless motors for its vertical propulsion and other maneuvers. In addition, a horizontal flight would require at least 1 extra motor for horizontal propulsion as well as a number of servo motors for different maneuvers. There is also a notable increase in the complexity of the design and control mechanisms. Drones will handle last mile delivery of most lightweight packages, example Amazon Prime Air. Currently, there are 2 kinds of UAVs One is autonomous aircraft to remotely piloted aircraft. According to a research report from Radiant Insight, unmanned aerial systems UAS markets at 609 million US dollars in 2014 are forecast to reach about 4.8 billion US dollars worldwide by 2021. This is sizable market growth with oil and gas mapping, utility line inspection, package delivery, and agricultural applications, accounting for virtually all the unit sales. Drones can provide more information at less cost than a human inspection team can, as per Radiant Insight in 2015. Amazon Prime Air is designed to deliver packages via a drone in just 30 minutes. Amazon is thinking beyond just home deliveries and already has designed for features like Bring It To Me, which would capture a customer's location by GPS, global positioning system data received through mobile devices. After many years of being tools used by military, drones have become very popular among commercial users and public safety. One of the areas of application where drones could have a big impact is firefighting remotely without human intervention. So, as specified, applications of remotes are infinite. Okay, it is left to the smart inventors, and sky is the limit, I would say, because there is no limit. Viewers who are more curious for more elaborate information may browse digital information readily available on net, besides research articles published on this topic. We'll meet again real soon. Rest in peace and harmony. Always watch these videos and with closed caption or subtitles for enhanced comprehension. As I have mentioned so many times, I have to rush through to complete the presentation within 20 minutes max. Hopefully, I presume I managed to meet the limitation I had set myself. If not, my heartfelt regrets to my genuine fans. Take care. Bye.